Okay, looks like it's live or getting there. Okay, so we are looking at old tests. So let me see if I can find one and share it with you. Got one. Here's a good one. Sharing screen now. Should be coming up on your screen in a sec. So I'm just giving you a second to digest before I go over anything. I'll give you about another 40 seconds. Oh, I'll see what's in the chat here. At least you recognize the type of problem. That's the first. Yeah. You know there's going to be some kind of graphical questions on the final because personally, philosophically, I think it's important to have graphical literacy. So questions that make you analyze areas, slopes, just points on a graph. That's the kind of stuff that matters more in the real world than kind of toy physics problems. So the largest force. Okay, so looks like people are starting to contribute. So let's go ahead. Okay, Nick, you think it's between -1 and 1. Would that be what you answer in block 2A? That's not what I want in the answer. Look what I'm looking for. Read carefully. Just make sure. I don't want where it is largest. I want the force. Do you see that subtle difference? So, okay, good. So yeah, you want the slope. Now take a look. Force is the slope here. So take a look here. This is a slope. You can get this slope right here. Okay, fine. But look at this slope right here. This looks pretty darn steep. So let me go ahead and undo my marks. I got to zoom in to get it. So what I would do is I would say something like rise over run. Whoops. Between these 2 points. It's not perfect, but that's the slope I would get. All right. So I'm going to zoom out so I can actually see everything now. All right. And so it looks to me like the rise is 2 EV. And this is the run is 0.4. And I think somebody said nanometers, right? Nanometers. And now you have to convert. So the force in the x direction is equal to negative rise over run which is negative 2 EV per 0.4 nanometer. And then you do your conversion factor. 1 nanometer is 1 E negative 9 meters. And then use this conversion factor as well. Equals the answer. Got it? Joy, I wasn't sure. Did you figure out what you needed, Joy? Jose, not sure what the -3 means. Because it's got to be something huge, right? Because you're going to get a, right, 1 EV and then 1.6 times 10 to the 19th or negative 19th. It's going to be tiny, right? So this 9 takes out 9 of those and you get a 10. So it's going to be something E negative or times 10 to the -10, right? Oh, that's the estimation before the conversion. I got you. Understood. So yeah, I'm expecting something on the order of 10 to the -10, maybe 10 to the -9. So it's probably going to end up being nanonewtons. Nanonewtons. All right. Determine the initial. How do you do that? I'll give you a second to think. I'll start the clock. I'll give you 20 seconds. Not to do it, but just to think of what you should do. Yeah, okay, energy. It should be a quick one. Was it initially at rest? Oh, I got you. Yep. So Alexis, yeah, he's on it. So in this case, we're expecting K initial. I'm just going to do the whole thing. And with these type of problems, we don't have external work. So that's good. So Alexis, how did you know to set K final to 0? What was the key word in the problem? Or anybody? What is the wording in the problem? Yeah, reverse direction. When you see this, anytime something reverses direction, you should be thinking, oh, V equals 0 for a split second at that reversal, at least for 1D motion, not for projectiles where there's 2D. But yeah, because it could reverse in the Y direction, but not the X. All right. So let's see. How about, so that says this is 0. How do I get the U's? How do I get the values for U? Look at the graph, right on. So so electrical engineering, this is a big deal, right? So we say it starts at -5 and it goes to there. So we would get this energy and this energy, right? That would be U initial, the red dot. This would be U final, the green dot, which is 2 EV. And this one looks like it's -4 EV. Now, wait a minute. Do I need to worry about the fact here that it goes down to -5 or it goes to -2? Do I need to worry about that in this problem? No. Now, where it might be tricky, what if I asked it to go from, what if I asked you to go from x equals 5 to x equals -2? How much initial speed would you need there? Or what would be the issue there? If I asked about how much initial speed do you need to get from x equals +5, but then I wanted you to reach x equals -2, not -5. If I wanted you to reach there, what is the limiting factor there? Does that question make any sense or not? Yeah, K final isn't 0. When you have problems like this, when I'm trying to go purple dot to purple dot, look for a hill. You have to get over this. So you'd say V equals approximately 0 at the top of the hill. And that's how you do that problem. So this would be initial. This is the hard part, getting over the hill. So you'd say this, you'd call this V final approximately 0, and you would use actually this, whoops, you would use the purple dot and the blue dot to determine how you get from the purple dot to the purple dot. Again, just in case my computer's lagging, if you wanted to know how to get from this purple dot over to this purple dot, you recognize that the blue dot up here is the limiting factor, and you do a problem initial and final there. Did that make any sense? That's right, because that's, yeah. Now, if I ask you to go to this point up here, whoops, let's do a different color. How about orange? If I ask you to get to this point right here, then notice the limiting factor is not the hill. If you're going to get over this hill, you're going to go up to here already. So then you know you'd use this point as final. And so if the hill is larger than the final height, that's when you need to do this goofy point in the middle. If the hill is shorter than your final point, you don't worry about the hill at all, or the valley. Is that good? Try to think of a roller coaster, and then I know this is really hard to think. Remember, the particle is not moving up and down like this. The particle is not going up and down. The particle is moving left, right along the x-axis. And this is just a measure of its potential energy as it moves left and right. Is that good on that? And Jay, I don't know, did that address your question, Jay? Sometimes you go purple to blue. Sometimes, yeah, like you said, I think what you said encapsulates all of it. All right. Let me find another problem. Got it. So you might have this all memorized from practicing earlier, but my apologies if you do. Still good for problem identification. I'm just giving you a minute and 20 seconds here additional to read. So at 6:21, we'll talk about it. About 25 more seconds, and then we'll talk. All right, let's go ahead and do it. So, part A, determine the angle. What do you do? Don't overthink it. Where's the chat? Can't see it. Oops. Yep. Sokotoa. Like the pub there. Do Sokotoa, right? We've seen this a couple of times. This happens a lot in statics, where instead of using an angle, we use lengths. So we've seen that one. Yep. And so cosine, something like that. And I'm assuming you make arc cosine. So that's good. Okay, cool. So now look at this. What type of problem is this one? Yeah, tension's a force. Makes me think about doing an FBD. Is this thing spinning around at okay. It's moving with constant rotation rate. Is it accelerating? Hmm. Any other thoughts? Take a guess, Jay. If you're moving with constant speed, are you accelerating? Yes, for circular motion, right? So I deliberately left my question poorly worded just to so we'd have something to talk about. There's no well, on the one hand, there's no acceleration, and on the other hand, there is acceleration. What kind of acceleration do we have here? Yep, AC. And so I think that's what you were getting at, right, Jay? What type of acceleration do we not have? Yeah. All right. Okay. So you're both right there. Good. Nice job. So FBD. All right. Let's see. Take a minute and do the FBD for this. All right. Try and do the FBD. Can we use a system FBD? Can we use a system FBD? That's right. You can use a system FBD. Friction would be internal. The blocks do move, Phil. But they don't move relative. Yes, good, good. Okay, they don't move relative to their position. Yes, exactly. Good. I'll go ahead and find the solution and bring it up here in a second. I'll let you work on it. Which question is on 10? So I'm just giving you a second to draw your own FBDs. I'll give you about 45 seconds. You can write the force equations too. That's good practice. So if you're making progress, just keep working on it. Try and get those force equations written out. I'll give you another 30 seconds just in case. It's kind of a tricky FBD and force equation, so. If you finish it, you could look at, if you get to a point where you know you could solve it, look at 10C. So if it's obvious that you would get the tension with just some algebra, then look at 10C here, and I'll let you keep thinking. All right, and let's go ahead and let's see here. I'm just going to pop up the solution and we'll look at it, right? See if there's anything that doesn't make sense. So for the system, hopefully that makes sense. L is not a force. A lot of people include the length on there. I don't know why, but yeah. Mu is not a force either. And this was probably the biggest mistake on this problem. It was not on the verge of slipping. So do not use F equals mu static N. And notice I did the lower mass FBD. So there was friction holding it towards the center, its weight down. There's a normal force up from the turntable. And this normal force 1, 2 is not not 4mg or whatever, right? This is not total weight, because, or it's not the weight of the upper block, because remember, this one is lifting up a little bit. So notice that, yeah, okay. So N12 is given right there. And we could see that N is not equal to all of the weight. So T cosine theta takes away a little bit of that right here. So yeah, the two common mistakes, I guess, would be this, or thinking that N12 was equal to 4mg. N12 is not 4mg. All right. And so I think from there it's pretty easy actually. And then part C also pretty easy. All right, so I'm gonna go ahead and stop the share for a sec. Let's see. Is that helping? Or is that good? Or did I skip too fast or whatever? All right, sounds good. Should we try one more and then call it a night? Let's take a look at one more. Are there any topics let me do it this way. Are there any topics you are scared about that I should bring up? Like old topics like vectors or 2D motion, relative motion. Okay, so let's look at some chapter 4 stuff. I'll see if I can find a chapter 4 problem, all right? Just looking for one here. I found one, but it's just too easy. Too easy. Oh, that was the hard one there. Let me pick a better one. Oh, that's a good one, but That's not relative velocity. Sorry, I'm having trouble finding a perfect question here. Let's try a more recent one. I was trying to dig around in some of the old ones to find something maybe you hadn't looked at, but ooh, that was a tough one. Let's try this one and see where it goes. And then I don't know if I have a relative velocity right here, but all right. So I'm looking at this problem right here. Let's scroll through this, and then we'll. I think the one after would be another one, so we'll look at it here. Student walks into a room, throws a ball upwards of 45 degrees. Just after the ball has left her hand is A. Max height is B. Point C is just before impact. The horizontal components are going to be that. These are the vertical components. Okay, so which one has the largest horizontal velocity? I'll give you a second there. Maybe I'll even scroll down just a little bit here. So you can do B as well. I'm trying to bring up my chat. Come on, chat. Where are you? There it is. Yep, all the same. All right, and so then how about the vertical velocity components? Assume 0 is bigger than a negative number. So which one's going to be the smallest? Again, read carefully. Assume 0 is larger than a negative number. Does that change your mind? Where'd that chat go? Come on, chat. Yeah, sorry about that. Yep, C is negative, then B, and then A is the largest, right? Okay. So you know that it was 0 up at the top. That's cool. Where is the speed the greatest? The speed. And I'll bring up the picture. So part D says, where is the speed greatest? Yeah, exactly. A. Okay, so don't think too much about this one because you know they all have the same X component. A has the largest Y component. So when you add them up, that's going to be the biggest. At which point is acceleration the greatest? At which point is acceleration the greatest? Between A, B, and C. It's all the same. Don't overthink it. Gravity's gravity, whether you're going up or going down. All right, let me see if this one had another one here. Oh, okay. So you could see, you're probably, if you're worried about relative velocity, you're probably going to be okay because I'm just looking at the problems that strike me and I'm not seeing a lot of relative velocity in here. So, yeah, I wouldn't put too much energy into that. Let me look for another one here. It's probably been a while since we did one of these. Let me find one. I'm gonna find one more for you. All right. Give me just a second. I gotta go somewhere for it. Let's see. Was it this one? No, not that one. Crap. Sheesh. There's so many problems now. I can't remember where everything is. How about we do, I think I can go this way to find it.
Hey, Jorstad.
Yep.
In the chat, Alexis was referring to the airplane problem on our
Oh,
test.
the plane. Let me take a look at that one. All
yeah.
right. Thank you. Let me see here. So old tests, 161, PDF exams. So 21A probably. Oh, this one. Yeah, I guess I think the hardest part for students is this one, right? This, right? You're supposed to know that that's the velocity, the speed of the plane relative to Earth. Relative to air. Excuse me. So when you see the speed relative to still air, that's your cue to know that. And if you know that, and like it could be still water, then it'd be a boat relative to water. But once you know that one, right, you know from relative velocity, you know that velocity of what are we looking for? Plane relative to the Earth, right? Plane relative to Earth is equal to plane air velocity plus air Earth. And so you kind of, and how do I know this? It's from this right here, the squeeze out, right? And that is probably okay, right? That part of it. Let me see what the chat says. Okay. And now this is the other thing that you want to get out of this. If you can't see this, it's really hard, right? You're supposed to see, this is the resultant. It's the sum. This is the answer. So these two vectors add up to that one, right? And so take a look. Wind relative to Earth. That's got to have something to do with velocity of air relative to Earth. So you can see that this number and this number are the inputs over here. They relate to the inputs, not the output. And if you see that, you can force the rest of it. You're like, draw a triangle. If you draw a triangle, it helps out, right? So in this case, you're like, okay, I know I'm going to do multiple triangles here. So in this case, and this is good. Let me, I need a little bit more space. So let me scroll down here. All right. So now in this case, the idea is, you've got the wind here and you've got, let's say, the plane relative to air. So we've got a blue vector, and let me see something here really quick. Directed due south. Okay, I got that. That's easy. So I know the wind is blowing this way, right? And now I know this is going to go, and so this is velocity plane relative to Earth, right? So I know that's going to be the output. Okay. And again, this is the first tail. This is the last tip. It's going to end up going this way, where this angle right here is the 22. How do I know that? Because I know VPE. It's all about using the vector addition to tell you which side of the triangle the different vectors are. right? I know that this is going to have to be, let's see, of the air relative to the Earth. So that's how I'm doing this in my brain. I'm just letting the tail to tip graphical vector addition tell me what to do. I know that these two that I'm striking here, these two have to add up to this one over here. I don't know. Does that make sense or not? I'm trying to let the words help me draw the picture, because once I get the picture, I'm good. I can do that. Now I know the side of an angle, and it's all just kind of straightforward from there. Or maybe not. I don't know. Is that helping? So this is just a basic vector addition problem where you have to think a lot to write down which vector goes with what. The most common mistake people made here was thinking this was 22, and that's not 22. This pink angle is not 22. Everybody just did that, and I don't know why. Didn't make any sense to me, but I don't know. I've got a strange version of thinking, I guess. All right, I don't know. That's probably pretty good. Let me see if I can find this other one here too, really quick. I have an old one somewhere. I know where it is. Let me see if I can find it really quick. Get all these marks off of here. It's probably just looking for it really quick. Yeah, I like this one. It's been a while since we did something like this. Notice this is from my 110 class, but whatever. It's just as good for you. So you won't have the solutions to this one, but see if you could start this one. And that's a good one to finish up with, because the rest you can kind of do later on your own. So I'm just giving you some time to look at it. Hopefully Whoops, it's getting kind of messy there, but you're getting an idea. Hopefully you're doing these kinds of things. And so it's if this is what came to your mind, good. And obviously you do kinematics from here, and hopefully that one's automatic. I'm going to pause and see if there's any questions. You could unmute or yeah, you just write down your kinematics equations and go nuts. And so you could tell this is 110. 110's a little easier, right? When I give you the time, it's like super easy. But the procedure and getting the list of knowns and unknowns is exactly the same. And that's where most students screw up, not in the math, right? So like a common thing is to forget the minus sign here on V initial Y. Or maybe when it's going purely vertical, you might have forgotten that V final X is 0. The milli, watch out for the milli. Got to get that kind of stuff right. So that's not too bad. All right, let's call that probably pretty good on that. So Alexis, you good with that? I think you're right on there. Do some kinematics equations, what you were describing to me, I believe. And then obviously you could get a distance, you could get the, so maybe to finish with that one, watch out. Remember that if I asked final position, that would be XY coordinates. Just a second. Whereas distance from the origin, so that's something, a way I might mix up. So on those kinds of questions, you want to watch out for the words position versus distance or displacement. Let me say it like this. So vertical displacement would be y final minus y initial, which might not be the same thing as the distance traveled, right? If you wanted the vertical distance traveled, you'd have to find the point where it reverses direction. So remember those tricks that if you reverse direction, you got to split things up and split it into chunks to get the distance instead of displacement. And then, of course, the old classic speed versus velocity. So those are just kind of a reminder of some of those old concepts that we used. Those are the wording issues that you need to look out for on the final, just so you don't lose ticky-tack points. Obviously, speed and velocity are different things. So if I ask for speed, I expect you to answer speed, not a velocity. Pretty good on that. Those kind of little, is that a pretty good super brief review there? Or any questions about that before we call it a day? Yeah. Are you feeling like, oh yeah, I can do that stuff now, right? It's been a while. Hopefully you're like, oh yeah, that's so easy because we did that so long ago. You're so much better now than you were. Yeah. In what way is it not easy, Jay? Or what's the part is it just review, general, get it fresh again kind of thing? Or is there a specific there's a lot to study, but it'll come back because you've been studying all semester. So that's something. Yeah, they'll be like, oh, what was that? Don't forget, you got a cheat sheet you can write, right? A 1-page cheat sheet. And I'll send out an announcement right after I get these damn headphones off my head. I'm going to go ahead and end the live stream now.